meta-analysis, which is simply analysis that combines data from more than a single study. We always need to have in mind in research more than just our study. So at the start of our study, we consider previous similar research, and afterwards we consider what comes next. Perhaps we will repeat the experiment, run a replication, or maybe other people will. And this replication experiment might be close, meaning as similar as possible to the original, just with a different sample, or we might deliberately vary it a little, ask the question in slightly different ways, or perhaps use slightly different population. And if we get similar results, that increases our confidence in the finding. Usually when you see a research result, the first question to ask is, interesting, but has it been replicated? Once we have more than a single result, then we can use meta-analysis to combine these results. So in our case, suppose we had two further similar polls that asked reasonably similar questions of a similar population of likely voters. What we're after is a more precise estimate. So here we have the first poll, mean and confidence interval, second poll, third poll, all presented in a lovely picture called a forest plot. I guess it's something to do with being trees and then the overall combination of these three results. You can think of it as a sort of weighted average of these 3-point estimates. By the way, do we prefer short confidence intervals or long? Pause the video for a tick and just think about that for a moment. Short or long confidence intervals? Well, you probably figured out that we much prefer short, because short means smaller margin of error, long means a larger margin of error, more uncertainty. So you've got to be a bit careful thinking about length with confidence intervals. A long confidence interval means our estimate is not so precise. There's more uncertainty. Short is better. Now here we've applied meta-analysis to calculate an overall result, and it's represented by a diamond, which is a good way to distinguish the result of a meta-analysis. So here is our point estimate at the fattest part of the diamond based on calculations from these three polls. And this length here is the length of the confidence interval, the interval estimate, calculated from combining all these three results. And here, this confidence interval, the diamond, is a little shorter than any of the others. It's a little more precise, and that's excellent. That's what often happens, and that's what we'd like to happen. So here is our meta-analysis machine. Take the results of a lot of individual studies on somewhat similar questions, and then it produces the overall result, which typically will be considerably more precise, a shorter confidence interval than any of these going in. And that's good news. The new statistics is a label I use for estimation as a general approach to answering research questions, and meta-analysis that combines evidence from a number of similar studies. New, well, the techniques themselves are not new, but using them as the main approach to data analysis would, for many researchers, be new and would be a distinct advance in the way they do research. Make beautiful music with confidence intervals. May all your confidence intervals be short.